Modeling with linear systems. How can you use a system of linear equations or inequalities to model and solve contextual problems? Modeling real-world constraints with systems. Real-world situations can often be modeled by systems of equations. Usually information about prices and the total number of items purchased is given, and the system is solved to find the number of each item purchased. Joe goes to the store to buy jeans and some t-shirts. The jeans cost $40 each and the t-shirts cost $20 each. If Joe spends $160 on 5 items, how many pairs of jeans and how many t-shirts did he buy? Write an expression to represent the amount that Joe spent on a pair of jeans. So for the jeans, they cost $40 each, and X represents the amount of jeans purchased. Write an expression to represent the amount that Joe spent on t-shirts. The t-shirts cost $20, and the number of t-shirts is represented by Y. Now write an equation to represent the total amount spent on jeans and t-shirts. So we have the two pieces combined for a total of $160. What variable represents the number of jeans purchased? That would be X. What variable represents the number of t-shirts purchased? That would be Y. Write an equation to represent the total number of items purchased. Well, they purchased jeans and t-shirts and got a total of 5 items, which it tells us up here. Write a system that represents the situation. So we're going to use both of those equations and put them in a system. Remember, they use the symbol like this to represent that it's a system of equations. What units are associated with the two expressions that you wrote in steps A and B? The original equation is talking about money. And it's measured in dollars. When you add the units for the expressions representing the amounts spent on jeans and t-shirts, what units do you get for the total amount spent? That is still measured in dollars. If you combine two units that are measured in dollars, you end up with a total amount in dollars. You can model real-world constraints, such as the number of items needed and the amount of money one has to spend with systems of linear equations. Example 1. Write a system of equations to represent the situation and then solve the system. A. Bobby will buy coffee and hot chocolate for his coworkers. Each cup of coffee costs $2.25, and each cup of hot chocolate costs $1.50. If he pays a total of $15.75 for 8 cups, how many of each did he buy? Create a table to organize the information. You can see that they used C as the variable for coffee and H as the variable for hot chocolate. Altogether, they purchased 8 cups. Then we have a situation representing the cost. So the cups of coffee was $2.25. The cups of hot chocolate was $1.50, and they spent a total of $15.75. Use the information to write a system of equations. So they wrote an equation for the cost, 225C plus 150H equals $15.75, and they wrote an equation for the amount of cups, C plus H equals 8. It says multiply the second equation by negative 2.25 to get the opposite coefficient for C. So they're using the elimination strategy for solving systems of equations, which we talked about earlier in our 8th grade year. And the way that you use the elimination strategy is you try and create opposites. So in this case, when they had a positive 225, they're going to try and turn this C value to be the opposite. And the opposite of 2.25C is negative 2.25c. So they're multiplying that whole equation by negative 2.25. And so then they're going to distribute to all parts of the equation. And it results in this equation. Then it says add the new equation to the first equation. So they've taken the original and they've taken this new adapted second equation and they're going to add them together. So when we add 2.25c and negative 2.25c, we get 0. 150h minus 2.25h gives us negative 0.75h. And 15.75 minus 18 is that negative 2.25. Then to finish and solve for h, they have to divide both sides by negative 0.75. And they end up with h is 3. When solving systems of equations, we have to find both variables. So now that we know that the hot chocolate, there were 3 cups, we have to figure out how many cups of coffee. So we can plug that 3 back into the original equations, and you can see here the h was swapped out with the 3, and then we can tell that we need 5 cups of coffee and 3 cups of hot chocolate to have 8 cups total. Here's another scenario. A student is buying pens and markers for school. Packs of pens cost $2.75 each, and packs of markers cost $3.25 each. If she bought a total of 6 packs and spent $17.50, how many of each did she buy? So we know that the number of packs totaled to 6. We know that the pens cost $2.75 each, and the markers cost $3.25 each. To form the equation, we are going to use those 2 pieces from the table. 2.75p plus 3.25m equals 1750. And the pens plus the markers was a total of 6 packs. Multiply the second equation by what to get the opposite coefficient for p? Well, if we're looking for the opposite of this, we would need to multiply by negative 2.75. Negative 2.75 times p is negative 2.75p. Negative 2.75 times m would be negative 2.75m. And negative 2.75 times 6 is negative 16.5. Add the new equation to the first equation. So we had that original 2.75p plus 3.25m equals 1750. And this new equation, we have negative 2.75p, negative 2.75m, and negative 16.5. These add to 0. That was the whole point of making them opposites. 3.25 minus 2.75 is 0.5m. And 1750 minus 1650 is 1. Then we have to continue to solve for m. We would divide both sides by 0.5. And so m equals 2. And we are replacing the m with the 2 in these one of the original equations. And if we subtract 2 from both sides, that means p has to be 4. So they purchased 4 packs of pens and 2 packs of markers. It says, what is another possible way to solve the problem? Instead of finding the opposite of p, we could have eliminated the m variable first. You could also do the substitution method by moving some pieces around, but that may take more work, or it may be easier for you, but that's another strategy. We have the elimination method and the substitution method for solving equations. A company has to buy computers and printers. Each computer costs $550 and each printer costs $390. If the company spends $8,160 and buys a total of 16 machines, how many of each did it buy? We have to write a system of equations and then solve it. So let's start with the amount of machines. If we combine the computers and the printers, we should get a total of 16 machines. Then we also need to think about the cost of those machines. We have $550 for the computer and $390 for the printers for a total of $8,160. Now we want to multiply this equation by either negative 550 to eliminate the c variable or negative 390 to eliminate the p variable. I'm going to eliminate p. If you choose to do this a different way, that's totally fine. You can still arrive at the same answer, so check at the end to see if you get the same result as I did. So I have that second equation, 550c plus 390p equals 8,160. And when I distribute here, I get negative 390c minus 390p, and 390 times 16 comes out to negative 6,240. So now we're going to see what can be removed. These add to 0. 550 minus 390 would leave us with 160 C's, or computer. And then 8,160 minus 6,240 is 1,920. To solve it for C, we divide by 160 on both sides, which gives you C equals 12. Now we have to plug it back in to figure out how many printers. So if we had this original equation and we replace the C with 12, we can subtract 12 from both sides, telling us that the printers, they had purchased 4 printers. Number 2, modeling real-world constraints with systems of linear inequalities. You can use systems of linear inequalities and its graph to model many real-world situations. Set up and solve the system of linear inequalities. It says Sue is buying t-shirts and shorts. T-shirts cost $14 and shorts cost $21. She plans on spending no more than $147. So that's where that less than or equal to piece comes in. No more than. And at least 5 items. So more than or equal to 5. Show and describe all combinations of the number of t-shirts and shorts she could buy. First, write the system. So X represents the t-shirts and Y represents the shorts. Since she wants to buy at least 5 items, they've combined the items to create an inequality. And then they've also written an inequality describing the cost. So graphing it, you see they've graphed them. Both of them are solid lines because they have the equal to symbol with them. They've shaded accordingly. And it says the possible solutions are where the shaded regions overlap. So in this section here. So a possible solution is 5 t-shirts and 2 shorts. And we can tell because if we go over to 5 t-shirts and up to 2 shorts, that is in the double shaded section. It says substitute this value into the inequalities to make sure it is a reasonable solution. So they've replaced the X with a 5 and the Y with a 2, which is greater than 5. And they've replaced the X in this part with a 5 and the Y in this piece with a 2. and they've multiplied by 14 and 21 and added them together, and they got 112 is less than or equal to 147, which is true. The result is two inequalities that are true, so this is a reasonable answer. But again, there are some constraints based on reality. We wouldn't want to say -2 shirts were purchased and 9 shorts were purchased. We want to make sure that the value we put in for X and Y makes sense based in the context. So it should be 0 or more t-shirts or shorts. John has to buy 2 different kinds of rope. Rope A costs 60 cents per foot, and rope B costs 90 cents per foot. John needs to buy at least 15 feet of rope, but he wants to spend no more than $18. Show and describe all combinations of the number of feet of each type of rope John can buy. First, write a system. Let X represent rope A and Y represent the amount of rope B. Then we have the 60 cents per foot of rope A, the 90 cents for B, and it says that he wants to spend no more than 18, so less than or equal to 18. And now we're going to graph the system. Remember, it may be easiest to transition it into slope-intercept form, so that one would be y is greater than or equal to -x plus 15. And then we can start our graph at 15 on the y-axis, and then it would be down 1 over 1. And it's going to be a solid line. And since y is greater, we're going to shade above. Then for the next one, we need to transition it into slope-intercept form as well. 0.9y is less than or equal to -0.6x plus 18. Divide by 0.9 on both sides. That leaves us with y is less than or equal to, that one can be reduced or changed into -2/3 x. And then 18 divided by 0.9 is 20. So we'll start at 20, and then we'll go down 2 and over 3. And that is also a solid line. And since it is y is less than, we're going to shade below. And it says, describe the solutions to the system. The possible solutions are between or on the 2 boundary lines. So between the boundary lines or on the boundary lines, since they both are solid lines. Write a system of inequalities for the given situation and graph the system. Then determine if the point 84 is a solution to the system. A student has to buy graph paper and printer paper. The printer paper costs $2 per pack, while the graphing paper costs $3 per pack. So we're going to do 2 for printer and 3 for graphing. She wants to buy at least 6 packs of paper, but spend at most 27, so less than or equal to 27. And combining the printer and graph paper together, she wants to buy at least 6, so more than or equal to 6. And then we will graph them. It does have printer as the X and graphing as the Y, so you may switch these to say X and Y, just as a way to make it easier for you to remember which way it's graphed. So if we transition this one into slope-intercept, it would say y is greater than or equal to negative x, because we have to flip it when we move it over, plus 6. This one, we would move the 2x over, and then we'd have to divide by 3. So y is less than or equal to negative 2/3 x plus 27 divided by 3 is 9. All right, I'm going to do the top equation in blue and the bottom one in green. So it starts at 6, and it goes down 1 over 1. And it is solid. And since it says y is greater than, it should be shaded above. Then for the green one, it starts at 9 and goes down 2 over 3. Down 2 over 3. Keep in mind the axes are not going by the same amount. The bottom goes by 2 and then the side goes by 1s. It is also solid and it should be shaded below. And then we have to check if 8,4 is a solution. It appears very close to that green line, so I'm going to plug in the points just to verify. If it is on the green line, then it is a solution, and if it is not, then it is not a solution. So we're going to plug the 4 into the y value and the 8 into the x value. So 2 times 8 is 16, so that is negative 16 over 3 plus 9. Negative 16 over 3 comes out to negative 5.3 repeating. And let's see, if I took 9 and I subtracted more than 5, that's going to come out close to 3.7, which is not bigger than 4. So no, it is not a solution. Now assume she wants to buy at least 7 packs. So the x plus the y has to be at least 7. And then the $2 for the pencils or the printer and the $3 for the graphing has to be at most 30. So again, we're going to transition these into slope-intercept form. This one becomes y is greater than or equal to negative x plus 7, because we had to flip it to the other side. This one would turn into 3y is less than or equal to negative 2x plus 30. And then we'd have to divide by 3, leaving us with negative 2/3 x plus 10. So for this blue one, we're going to start at 7. We will go down 1 over 1, and then that is going to be a solid line shaded above. And for the red one, we're going to start at 10 and go down 2 over 3. Which is a solid line shaded below. Is 8,4 a solution now? Yes. 8,4 is a solution, since it is in the double shaded region. Or overlapping shaded section. Is it possible for a system of 2 linear inequalities to only have one solution? No. It can have a region or a shaded section, it could be the same as one of the inequalities, like we saw in earlier lessons where they matched up, or it can be a no solution. But having one solution is not going to work in an inequality situation. Why can't a system of inequalities be solved using the same method as solving systems of equations? If we were to use the elimination method, we can't plug back in a range like if we were to solve it in an equation situation, it might say x equals 5. Well, we can plug back in x equals 5 and solve it for the other variable. But with an inequality, it might say x is greater than 5. We can't plug in all of those values to solve for what all of the other possible other variable could be. Then in 9, when writing a system of equations or inequalities from a situation, how do you know that you have possibly written a system correctly? Well, you need two equations or two inequalities. That address different aspects of the situation. So for example, in the printer and graphing paper situation, we needed an equation that addressed how many packs, and then our second equation addressed how much money. Same thing with the pencils and markers. We had an equation that addressed how many items were purchased, and then one that addressed how expensive or the price for it. We've also talked about different things with like basketball, how many shots were taken and how many points were made, and those sorts of things. There's two equations or inequalities, and they address two different aspects of the situation.